sempat nanti saya akan cover tutorial. Otherwise, just go into deep into what is thermodynamics table. So, nanti kalau ni tak payah ni saya. So saya rasa you all semua dah ada thermodynamics table dekat you all punya ni. So walaupun kamera ni tak berapa clear, no why? Why? Dia cuci pun dia tak clear juga. Kena beli kamera. Kau hadiah kan? Harga $1 juta, $2 juta. Ni pun dah kira canggih ni kamera saya ni. So any student saya, ex-student saya kasih hadiah ni. Kalau saya nak beli pun tak mampu ni, RM500 ni, Logitech ni. Right? So these are the thermodynamics table. So it's at the level at A1 and A2. Okay? A1, A2, and then if you go into the next page, there is B1, B2. Right? And then the next stage is C1, C1, C2, okay, then C3, C4, C5. So there are A part, B part, and C part. Okay, the A part and the B part are the same because when the question later on, let's say the question start with pressure, then we use table B, B1 and B2. If the question gives you temperature and other properties, then we use table A. So that's the only difference. Okay, they are the same table. The only difference is that table B ataupun B1 kat bawah tu, okay, so this table is the start with pressure. Okay, but for A1 and A2, the page A maksudnya page 1, page 2 lah. So the first one is front page, and then the first page is the first two page are A1 and A2. The following two page is B1 and B2. The remaining are C. Okay, the C1, C2, C3, C4. Macam bom lah. So this one is known as temperature first. For table B is pressure first. Okay, the result here are almost identical on both sides. Okay, the only difference that they look into the temperature first and the table B look into this pressure first. Okay, so kalau nak clear nanti saya tunjukkan yang dia punya yang table yang macam you lah. Jangan. Atau so malam ni going to be very slow. So you guys can catch up. Thermodynamics table, mana table lah. Lama, saya bila cari tak jumpa. Saya tengok kat group saya kita. So you all ada table, you all ada print table kan? Saya dah bagi kan, saya rasa kan?
Dah.
Saya takut saya lupa bagi. Okey, kalau dah bagi okey lah. So yang bawah tu dia dah tulis B1, B2, A1, A2 kan?
Sir.
So sekarang you tahu lah. So jadi betul lah, saya takut saya bagi silap table So the below one is A1, A2, B1, B2. So A1, A2 and B1, B2 are the same table, but the difference is that A1 and A2 is start with temperature, but for B1 and B2 they start with pressure. So that's the difference. Okay. And later on, when we identify that the system are superheated vapor for the water, then from there we use table C. Okay, so table C ni yang C1, C2, C3, C4 ni only for the case of superheated steam. Okay, otherwise we only use table A1 A2 or B1, B2. Okay. So if you look into table A1 and A2, okay, A1 first. So the A1 is that the water start from 001 degrees Celsius, 5, 10, sampai lah until 374.14. That's mean when we learn during the SPM, so or mungkin the one of the Arab person probably in their country they call it O level. Okay, so we say that the saturated water, the hot boiling water is 100 degrees Celsius. So while learning thermodynamics, the hot boiling water 100 degrees Celsius is not true. So the maximum temperature of the water can go up to 374.14. Okay, and the water pressure can start from 0.6113 kilopascal until 22.09. Okay, so the water temperature is 374.14. So the pressure is 22.09. If you look on this side wall, it's the same. If the maximum temperature is 372.14 for A1, and the saturation pressure is 22.09. Okay, these are the maximum from the water. So if your mom asks you to boil water, then you ask your mom. So if you, mom, what sort of temperature that you want for me to boil the water, to heat the water up? Okay, say I want the temperature of 200 degrees Celsius. So in order to boil the water and reach 200 degrees Celsius, you must use a container or something to boil it with the pressure of 1.5538 megapascal. Okay, that's why later on, if you work in this company like Silterra or something, when they use to cool down this machine and all these things, they use water to cool down it. Okay, like to do some wafer fab technology or something like that. So they, in other words, they use water to cool down the machine, the process and everything. So they have a water treatment. So there is a water treatment engineer. Okay, why? Because the water can be heated until 374.14. And that's why in order to cool down also the nuclear power plant, they use water, the seawater, to cool down the temperature. Because the water itself can capture until 374.14 degrees Celsius at the pressure of 22.09. So again, if you look at this A1, A2, and B1, B2, they are almost identical. The only difference is that for B1 and B2, the problem start with pressure first. And then for pressure, when we solve the question, they start with temperature and other properties, then we use table A1 and A2. So it's clear. When we know that the water is in superheated condition, later on I will explain what is superheated, what is saturated. Then from there, we can say that it is a superheated water vapor. Then it is UN. Then from there, we start to use table C. Otherwise, only table A and table B. Only for superheated condition, we are using the table C1 until C1, C2, C3, C4, C5, C4. Because when it is superheated, the pressure, where we call it superheated, the pressure can go unto 60 megapascal and the water can go until 1,300 degrees Celsius. Okay, that is beyond the capability of the water, and the water can go up to this high of temperature. Okay, so that's itulah kehebatan water. Yeah? The best part of the water until 1,300 degrees Celsius. Okay, that's why they use water to cool down the fire, and even there is big explosion, they still use water. Why? Because by learning thermodynamics, we can say that the fire brigade can still what matikan apa tu, can still kill the air, the heat by using water. Okay, based on the higher pressure and higher temperature. So there's some application when we look at this table, right? So before we solve the problem, so I don't think that we have chance to solve this problem tonight, but I'll teach you guys on how to know that. Okay, so if you look into table this one, so you want to know what are the properties that we talk. Okay, so okay now, so this is megapascal. So these are V. So saturated liquid. This one is saturated vapor. So you can write here small v. So if you look into A1, so small v in meter cube per kilogram. So these are VF. So VF, this is VG. Okay. And then on the right side is internal energy. So internal energy is U, small u. Okay. So if it is internal energy is not a saturated liquid, it's UF. F refer to saturated liquid, atau in Malay we call it cecair tepu, something like that. And then G is saturated vapor. Okay. In the middle, we call it FG. We call it a mixture. Mixture of saturated liquid and vapor. Okay. VAPOUR. Tulisan doktor dia salah kan. So vapor. Right, mixture. So FG is a mixture. If what is FG? UG minus UF dapat UFG. Because the column is not enough, so the author didn't calculate VFG. So VFG, how to get VFG? Equivalence to VG minus VF. But for U, they give UF. For HG, so just let's say for UG, so 23753 minus 3 minus 0, so you got UFG. So the UFG, HFG and SFG, yang ni you takkan belajar lah because you are not a mechanical student. You akan belajar these three saja. V, U dengan satu lagi enthalpy. Enthalpy is known as H. Okay, so malam ni kita nak kena table saja. Right. Okay, so for enthalpy condition, again, if it is a saturated liquid enthalpy, then HF. If it's mixture ataupun evaporation, so you call it HFG. Saturated vapor is HG. Okay, ni S tak payahlah, you tak pakai ni. Right? So if the question, let's say it is a mixture for the problem that was given to you later on, so that's mean to get the value of VFG, so VG minus VF. Okay, again, dah ulang 2 kali dah. Right, so it's very clear. So kalau tak ada, in case you have a question, stop me directly. Jangan tunggu dah habis baru nak tanya. So even budak mechanical pun they have problem to understand this table. So it's getting worse when you are electrical engineering student. Tapi the funny thing is that the electrical engineering student they score the thermodynamics punya lecture exam rather than the mechanical. Mungkin sebab mechanical ada satu lagi part kot. Probably that. But you guys can score this. This is very simple application, right? So specific volume, specific internal energy because it's small u, specific enthalpy. So VUH, volume kita dah belajar. We know a little bit based on the previous class, you know what is volume. And I also mentioned a little bit about the internal energy. So you guys know a little bit about internal energy. H, we will later learn in next 1 to 2 weeks time. So, but this Friday will be lecture, a very basic lecture related towards the saturation of water, saturated water and saturated liquid. So we go into detail on Friday morning. Okay, right. So these are the tables. Okay, right. So now, what does it mean by when? How do we use this table VF, VG, UF, UFG, UG? HF, HFG, HG. Okay, right. So now, so for tonight, I'll show a little bit example, a little bit exercise. Okay, so the saturated liquid. So let's say we have, so this one is a very general question, example. So now we have, ni kita belajar melukis TV diagram. So tonight is about TV diagram. So this is temperature, these are volume. Okay, so these are the temperature, these are the volume. Okay, the volume. So we call it TV diagram. This is saturated liquid line. This line represent the saturated liquid ataupun this line show about, in Malay we call it the cecair tepu. So this line more than this line is known as cecair tepu. If touch this line is not above this critical point. Okay, so when it touch slowly down here, okay, dia bukan macam tu Macam ni bukan macam tu, dia macam ni, dia kangkang sikit kat ujung. Right? So this above this critical is saturated vapor. So garisan ni adalah garisan saturated vapor. Saturated, so SAT dia saturated lah. Saturated vapor. Jadi kita tanya pula SAT tu apa? SAT tu saturated. So all this line is known as saturated liquid. Okay. Nanti hari Jumaat saya akan ulang balik. This one is known as, tapi hari Jumaat ni kita pakai PowerPoint lah. PowerPoint dia tak seronok, dia macam mengantuk. Okay. So malam kena buat macam ni, kalau tidak nanti saya mengantuk terbalik pula. Right. So this is critical point. So the critical point that differentiate between water, liquid and vapor. Wap. Kan? Vapor ni wap lah. In Malay we call it wap. In liquid call it cecair. Cecair. Sorry lah, saya tak belajar kat Malaysia dulu kan. Mulchil. Kalau Korea dia panggil mulchil. Mulchil. Okay. Right. Dulu belajar macam ni bunyi. Dulu balik Malaysia dia kena ubah habis semua. Right. So now we have a line. This should be a straight line. Okay. Straight line. Bukan kali lah. A straight line. Okay. And then this also straight line. Jangan bengkok lah. So make sure kalau macam ni, so dia macam tu. Okay. Right. So dia lukir-lukir ni. And then straight line upwards. Okay. So straight line, straight line, straight line. Esok kalau exam macam-macam ada gambar macam ni. Macam ni ada gambar. Ni macam yang Zahir punya. Macam ni macam-macam. Dia punya shape dia. Tak seronok tak ni. Right. So ni solution. So nampak air saya ni? So air saya ni dalam keadaan liquid. So liquid, let's say at 20 degrees Celsius. Okay, ni temperature dalam degree Celsius. So it is at 20 degrees Celsius. So it's known as here. What is it? 20 degrees Celsius. Let's say it's 20 degrees Celsius. So this is known as this area. Kalau dia berada di sini, macam air saya tadi tu, is known as compressed liquid. Okay. Okay, so compressed liquid. Kalau dalam table ni kita nak cari compressed liquid, tak ada. Okay. So, bacaan yang paling hampir untuk compressed liquid adalah di dekat point sini. So, compressed liquid, kalau kita perlu, we need to find if let's say the problem said, saya selalu tercakap Melayu lah, sorry. So, if they say that, when we need some, if the problem say that, based on our interpretation that the first state is known as the state of compressed liquid, then the value of volume we read is close to the volume of, let's say 20 degrees Celsius. So this one. So let's say the volume of VF. So probably for my liquid water now is 20 degrees Celsius is 0.001002 meter cube per kilogram. Okay, so tonight class nanti 9:30 lah, sebab saya 9:30 saya ada kelas lain pula. Saya sibuk. Semua kelas free malam-malam ni. And then, okay, so, okay now. So here is, let's say the problem we say that, we know that, let's say later on I teach you guys lah, later on how to know that this is saturated liquid, this is saturated vapor, right? So let's say now, the problem that we give, they say that it reach until, the problem is say that it is a saturated liquid. So saturated liquid is here. When the problem say that the value is touching this point, is known as saturated liquid. So the V volume is volume of this one, saturated. Ni kalau tulis macam ni sama dengan 0.001002 meter cube per kilogram. So if touch this point is known as VF. Okay, this point, exactly touch this point is VF. Okay, and then, so katalah when I hit this thing, so this become, so half of this become, apa ni? Let's say it's become half the same volume, but when we heat it, half of it become vapor, half of it become still maintained as liquid. So let's say here, okay. So from this point until before touching this point is known as, we call it mixture. So this is what is represented as before I explained, FG, mixture. Okay, so these are the mixture, state of mixture. State of mixture. Ni tak ada, so bila tak ada, kena calculate VG minus VF. Okay, so that's for clearance for this thing. Okay, so VF. Right. Okay, so settle. One, let's say the problem now say that the problem is the state given. Contoh macam soalan tutorial kan. So in the tutorial say, so if they say this problem are saturated vapor and 900 kilopascal. So saturated vapor is the point that touched here. So the point that touched here is known as VG. Okay, so kalau kita baca sini nilai VF, so ini nilai VG yang kita baca daripada table. The value of VF and the value of VG that we read from the table. Okay. Okay, so touch this point is VG. Okay, let's say the problem now is superheated, then everything above here is known as superheated. So these are where we refer to table C1 until C7. Tak ingat C4, C5 macam tu lah. Okay, so this area is known as superheated vapor. Dalam bahasa Melayu we call it wap lampau, wap tepu terlampau. Dia macam over wap lampu terlampau, superheated. Okay, so superheated, that's why the table here until VG ataupun nanti until VG, until UG, until HG. So same lah kalau kita ubah HG, HF, HG, UF, UG, kan tak ada masalah. So the value are the same. Okay, HF, HG. So if above this point, so you cannot you cannot refer to either table A or table B, or B1, B2 or A1, A2. You have to refer to the table C. Okay, because it is on the superheated region. This one we call it region. Region in bahasa Melayu we call it negeri. So the region of Kedah, the region of Malacca. So because it's too big, now we call it state. And when the people live in that region, we call it a state. Okay. So that's English one. English word is very dia macam bahasa Arab. So they are compromised of a lot of meanings, dia punya semantic dia punya synonyms dia punya thesaurus dia. It's unique. Okay, right. So that's about this saturated compressed liquid. So compressed liquid area ataupun compressed liquid region, saturated liquid point, saturated ataupun mixture. Dia kadang-kadang here they call it, okay, just call it mixture. When you kill mixture, just say mixture, so that means I understand that it is a saturated water, which is liquid, vapor, mixture. So dia campuran air yang liquid dengan wap. Okay. So saya dah ajar 2 kali ni, so I explain in Malay and explain in English. So hopefully you got twice punya processing, you punya brain can process. And because I'm repeat again. Right? Okay. So you understand compressed liquid, saturated liquid, mixture region ataupun saturated water vapor mixture region, and then saturated vapor tepu. Okay, and then this is known as the area for ataupun region of superheated vapor, wap terlampau. Right. So this line is the line that represented by as a P pressure. Okay, so let's say the pressure is 10 megapascal. So if the problem gives you 20 megapascal, that means you have another one here. So this line is refers to have P equals to 20 megapascal. Okay, very clear. So kalau if the question say that the third phase is about 5 megapascal, so 5 megapascal is down here. Right? Okay, so P equals to 5 megapascal. If you look into thermodynamics books, there are PV and TV. Okay. So PV yang kita belajar today is this one. But PV is different. Like this. So forget about PV. Enough for you guys to understand TV. You guys might wondering how do we see in industry. Industry nanti you dah baca table, you dah baca this kind of meter lah. So how this meter is coming out dekat TNB tu kan? Based on the theory that we learn today, very basic. Okay. So macam you belajar V equals to IR semua tu kan? So bila you tengok dah besar-besar, it's more applied. So more applied than go advanced. But the basic of everything is coming from today's punya lecture lah, kalau for thermodynamics kan? Untuk steam power plant nanti. Right? So far, everything is clear, is okay. I think you guys can understand. So, faham tak ada apa-apa soalan sebelum saya move on. Okay, tak ada. Okay, kalau tak ada, then kita just look into this question lah. Okay, kita semakin kabur. Okay, clear sikit kot. Right. Okay, now this problem, so nanti in midterm final dia tak macam ni lah. In midterm final, in this first sentence describe this criteria. The second sentence normally describe the second part of the problem, that example. The third part of the sentence explain the third criteria. Okay, but for the purpose of teaching you how to learn the thermodynamics table, so I make it as simplified as a tabulated table. Assume that the final exam when you interpret it is you say that this is A. So second sentence display the temperature, water pressure is about blah, 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 blah. So that is B. Okay. So for this purpose, then okay. Now we have, in order to identify the phase description, we must know at least two properties, either T and V, P, or where they give you a saturated vapor, or they just give pressure and temperature, or just a simple 242. Sini soalan ni tak payah kita. So tonight we just solve this two lah kot. Okay, nanti yang lagi dua ni you all boleh solve. You try to solve. Okay, right. So 55 degrees Celsius, 7 and 7.2. So now, okay, we draw the TV diagram. Okay, TV diagram. Okay, so TV diagram. We have one pressure. We don't know yet the pressure. Okay, we don't know what to put here. P equals to how many megapascal? Okay, we don't know yet. But we know that temperature is 55 degrees Celsius. Okay, let's say if you look from the table A, the unique about table A, they give you temperature, A1 and 2. So at 55 degrees Celsius is what? So VF is 0.01015, 9.568. Okay, so this is VF. So VF VG. So VF from the value is from here at 55. You look at the table, 0.01015. Ni dalam tutorial pun ada, dalam YouTube ada. Yes, apa dia?
Bukan dia punya unit dia kJ, kilojoule. So bukan guna entalpi ke internal energy.
Tak, ini V, soalan kedua. Dia ada dua kan,
Okay.
dua table. Yang bawah tu. Jangan tengok yang atas tu H, yang bawah tu V.
Okay.
Okay, yang H tu nanti. Okay? So yang saya ajar malam ni dekat YouTube dah ada dah. So jadi saya nak tunjuk step by step yang kau you guys boleh ulang banyak kali, you guys akan prefer yang mana satu yang senang faham. And then VG is what? 9.6568. Kalau saya silap baca, itu orang bagi tahu sebab mata tak apa nampak. Dah tua-tua ni. 568 meter cube per kilogram. This one is meter cube per kilogram. Ini tutorial 1B yang bahagian bawah punya table. Soalan 2. Right. So, the question you have 55 degrees Celsius. Okay. And 7.72. So, 7.72 is what? Is in between VF and VG. So, these are, so we know that this is state of saturated mixture or just water vapor. So just write mixture saja. Okay, so we know it's a mixture. So what are the pressure? So the pressure is what? 55. So we can read because this is saturated. So 55 is what? 15.758. So 15.758. So kita boleh tulis kat sini 15.758. So because here only this part mixture we have the value of X. Okay, so how to get the X? So the X have a formula. In theory later on, where I will teach you guys on Friday, when mixture, so these are the formula. Okay, XVFG. The V is given here, 7.72. Tolong pakai calculator boleh tak? Saya lemah sikit nak tekan calculator malam-malam ni. VF is what? 0.001015 plus X. So, because there is no table VFG, so VG minus VF. So, 55. 55. So, VG minus VF. So, 9.568 minus 0.001015. So, dapat berapa X? Lama. Berapa X sayang? 9.568 minus 0.105 X. So dapat jawapan X ya. Katalah A. So put it A. So kalau nampak ni tulis kat situ A. Lagi ada orang tanya tulis X lah. Orang tanya apa saya tulis A pula? Ada tak cerdik tu, ada sudah tak cerdik juga orang dia tanya. Kenapa tulis A? Tapi kat sini atas X. Yalah, X tu sama dengan A nilai dia. Nilai dia berapa? Saya tak calculate. Mana saya calculate lah. Right. Okay. So dapatlah jawapan. So we have fill out this first phase. So normally X.
Solution tu memang kena buat loceng tu, memang kena buat TV diagram tu.
Kalau boleh lah, kalau tak nak buat pun tak ada masalah. Tapi kalau tak nak buat, kadang-kadang kalau you tak buat benda ni, you tak tahu lah nilai dia kan. Nak solve dia kan. Walaupun soalan tak minta, tapi kalau you tak boleh, you tak reti TV diagram, you tak boleh buat. You cannot answer it. You tak tahu jawapan dia apa. Right? Okay. So it's very clear. Now we solve the second. So kita try sampai C lah. You try buat lagi dua. So lagi dua ni jawapan dia dekat YouTube lah. Okay. Right. Okay. So B, you have 900 kilopascal and saturated vapor. Okay. Okay. Yang tadi kita tengok table A. Sebab apa? Why we look at the table A, which A1, A2? Because the question start with temperature. But here, the question start with pressure. And they give you the phase description. So when the pressures, then we look into table B. Either B1 or B2. Okay. Okay, now. Aku punya table pun dah boleh hilang. Alamak. Table. Okay. Alamak. Table saya dah hilang. Macam ni. Tua ni. So 900 kilopascal, berapa megapascal? 900 kilopascal 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 ber
0.9.
0.9. Okay.
0.9.
0.9. So again, tadi ada yang tanya pasal TV diagram kan? So draw another TV diagram. So nak belajar temu ni. Saya dah mengajar 20 tahun pun dekat Malaysia, dekat India, dekat Belanda, kan? Dekat Australia. I still love this subject. Dari subjek lain saya ubah-ubah, tapi kalau subjek ni saya tak tinggal. Every sem saya ajar semua pada budak mekanikal.
Kenapa letterin nak kena belajar temu je?
Kalau you kerja steam power plant, dia overheated, dia meletup. So katakan you baca table-table kan, kalau meter banyak tu kan. So how this meter is working? So based on the working principle yang kita belajar malam ni lah. Ya, kadang-kadang macam AutoCAD lah, bila ataupun you pakai software kan. So, software tu coding tu macam mana? Coding tu daripada mathematician yang develop lah. Itu yang pentingnya. Right? Tapi satu lagi, kalau you kerja oil and gas, esok tu you pakai turbine system, still pakai benda-benda macam ni. Right? Sebab untuk cool down, cuma dia pakai air. Bila air dia ideal gas, dia tak pakai thermodynamic table, dia pakai gas. Table, dia pakai gas PV equals to MRT. Okay? So now dia bagi you 0.9, so you can draw straightly P equals to, convert into 0.9 megapascal. Why did I ask you to guys what is in megapascal? Because the table here is in kilopascal and megapascal. So if it's in megapascal, then there is 0.9. So 0.9 is here. Okay, 0.9. Okay. So 0.9 is 175.38. So that means all the temperature along this line, saturated line, maksudnya tepu, is 0.9, 175.38. So ini degree Celsius kan? Okay. Right. And they say what? They say the phase is what? Saturated vapor. Yang tadi so kita cari, they want you to find what is a phase. Now they give you phase. So bila they give phase lagi straightforward. So this is saturated vapor. So the value of V is what? V is the value of Vg. Kan? Bukan di saturated vapor. So baca Vg dekat 0.9, 0.215. So 0.215. So ni pula dia meter cube kan, meter cube per kilogram. Silap volume atas tu silap meter cube per kilogram patutlah kawan tadi tanya kan. Okay, sorry. Ini meter cube per kilogram, bukan kilojoule per kilogram. Okay, meter cube per kilogram. So kalau dalam tutorial you all over V meter cube per kilogram, H baru kilojoule per kilogram. Right? So Vg is what? Vg 0.9 is 0.215. So 0.215 meter cube per kilogram. What is X? X is 1. Kenapa 1? X is start from 0, 0.1 sampai 0.99. Bila dia touch saja, 1. So kalau dia touch ni, kosong. Okay. So kalau saturated vapor, X dia akan tulis kosong. Saturated mixture depends on the calculation. You calculate X dapat berapa. So kalau X dapat 0.3 tadi, 0.5 atau 0.6. Kalau calculate tadi, tak ingat. 0. berapa? 0.654 3. So this one is 1. Okay. So what are the temperature? Because it's the straight line, dia semua dia dalam masih dalam line, so 175.38. Midterm you all akan score lah kalau you pandai isi table ni. Okay. So dia dah isi table ni. Cuma in midterm and final dia tak bagi dalam table macam ni. Dia dalam especially final exam dalam bentuk ayat. So you convert dalam bentuk ni. So saya ajar macam bentuk ni dulu. Nanti bila ada ayat ni pun saya akan ajar bentuk macam ni balik. Right? Okay. And then, so the last question for tonight, because it's already 9:13, so I'm going to another class at 9:30. So 200 and 500 degrees Celsius. So masih nak pakai yang ni kan, mampu semua nak buat satu table lah. Baca. Okay. So saya tulis sengit, that's why kalau you nampak graf saya sengit dalam kelas ni kan. Sebab saya tak boleh tulis straight lah. Saya tak tahu apa masalah. So So kalau ada T, ada P, nak tengok mana dulu? So this is T, this is P. Okay, kalau saya akan tengok P dulu. Saya akan tengok table P. Okay, so if B is, kita tengok B. So this one is, kenapa saya tengok B dulu? Sebab I want to put is here. P equals to, so 500 kilopascal is 0.5 megapascal. Tu ada yang tak cerdik tadi kan, apa pasal 0.15 kat sini kau 500? Yelah, dah dikonvertkan ke dalam megapascal. Okay. Okay, so 200 degrees Celsius. So at 0.5, based on table B, 0.5, so temperature is what? 0.5, temperature is 151.86. So 151.86. 6 ni is along this line. Okay. The question say what? 200 degrees Celsius. So 200 is higher than 151.86. So 200 is here. So this is the area of superheated vapor. Nampak? So bila kita tahu ada superheated vapor, then we look into the table C in order to find V. X tak ada lah, X just put nil lah. Sebab lebih pada sini, tak ada X. Sini pun tak ada X, sini tak ada X. Yang ada X, kalau di touch this one is kosong. Between here is 0.1 until 0.99. Touch here is 1, above this one, no. In case you calculate, you akan dapat 1 point something something, jadi tak payahlah. Tak payah, data is not that important. Kan? Sebab apa? Sebab bila ada uap tepu, so first dekat area sini, these are the water, the liquid water. But when enter this region, okay, region ni kat sini, kau tak kat sini. So, region ni, dia akan jadi, sini vapor, sini liquid. So, kalau kat tengah-tengah ni, daripada daya asal this kind of thing, so dia separate into two. Half of it is water, half of it is gas ataupun vapor, wap, kan, wap, steam ke, steam, vapor, they are the same thing. Okay, wap, they are same wap. Okay, faham tak? So that's why sini kalau macam ni mungkin X 0.5, macam soalan tadi kan, mungkin dekat tengah-tengah ni. Untuk
So,
soalan
Cik,
ni
X tu boleh kita define sebagai ratio untuk vapor dengan liquid ke?
Yes, the vapor ratio untuk mixture of saturated and steam. So bila superheated is this kind. So dia dah tak ada dah saturated, tapi still the mass are the same. Katalah 5 kilo, tetap 5 kilo semua ni. But here is all are in a steam phase ataupun superheated phase. Kalau sini, okay. Bila dia ni, dia lagi panas ni. Kalau belah sini, dia lagi panas. So dia dah overheated. That's why kita pakai table C. So bila table C, so kita tengok table C 0.5. Mana table C? So table C, where's the table C? So table C 0.5. Mana 0.5? Mana table C? Sekejap, aku pun cari table aku, mana table aku. Okay. Okay, so table C 0.5. So 0.5. So kita tengok atas ni lah. 0.05, 0.1, 0.4, 0.5. 0.5 megapascal. Right? 0.5 megapascal. So saturated is 1.1486. So that's why graph kita tadi 1.16 is around this line. Now it's 200. So ambil 200. So 200 is here. So V is 0.249. So V dekat sini, yang soalan tu ialah 0.4249. So kita boleh tulis kat sini 0.4249 meter cube per kilogram. Okay. Clear? Right. So superheated dan saturated vapor punya datang, mixture punya datang. Kan? So nanti kalau hari Friday, so it's going much easier if you come to that punya class. Right. Alamak, tu pakai record. Tak apalah. Ya Allah. Tengok kat YouTube je lah. Siapa ni? Right. Rasa lagi satu. Kau cukup dah? Satu lagi
Boleh lagi satu lah.
Boleh. So last So 120 degrees Celsius. Apalah seorang minta apa kita buat je lah. Zahir mana Zahir? Dia suka mencari Zahir.
Ya, saya.
Hey! Lupa hal bye.
Kurang fokus.
Oh ya ke? So kangkang sikit pula sini So saya suka buat macam ni, saya buat T. Okay.
So macam tak nampak sangat saya.
Tak nampak atas sikit. Okay.
Okey, ngam.
Cebok. So 120. So 450. So this line represent P equals to 0.45 megapascal. Macam mana pula dapat 45? Sebab soalan ni 0.45. Ada yang tanya tu. Dia senang dalam kelas. 1/3 blur, 1/3 understand, 1/3 is 50-50. Dia nak faham dan tak faham. Itu standard budak UTM FTK lah. Itu dah biasa lah. Okay. Right. That's why kita masuk universiti, we learn the basic fundamentals. Okay. Bila dah advance nanti dah pakai mesin-mesin semua, you tak tengok dah benda ni semua. Bila rosak, burn, you tak boleh buat apa. So, you tak boleh sebab you budak teknologi nak troubleshoot. Nak buka mesin semua tak reti benda-benda ni semua. Kalau you kerja bahagian ni lah. Kalau jual insurans tu tak ada lah. Right. Okay. So 0.45 dia bagi apa? 120 degree Celsius. Dia bagi dua ni. Okay. So jadi kita tak tahu 120 ni is in from the question. 0.45 is what? So because it is start with the pressure, so we look table B, 0.45. So 0.45 is what? 0.45 is
147.
147.93. 147.93. Okay. Soalan ni bagi apa? 200. So 200.
120.
120. So 120 is below here. So bila below, so it is a compressed liquid. So it's a compressed liquid. Maksudnya dalam keadaan yang cari tipu ni macam air kan? Cari tipu. Okay. That's why water bila kita letak kuih, bila kita keluar 90 degree Celsius, we can still see the water with the steam. Kalau kita letak kuih buat air di dalam apa 50 kan, nanti keluar semua angin ni, awak ada mesin ni. Itu kena tahu. Kenapa kuih buat 90 degree Celsius? Because we can still see the saturated liquid, the compressed liquid. Right. So compressed liquid, what is X? Tak boleh buat. X boleh buat macam ni ataupun boleh ini. It's not liquid. So what are the value of because there is no value here of saturated ataupun compressed liquid. So we believe that this here punya bacaan dia. So the V here is approaching the value of it. So value kita tak nilai keadaan masih sama. Masih water lagi. So V equals VL is what? What is VL? 0.1 0.0 Okay, so that's a compressed liquid. Tapi kalau nak find example, you just say as compressed, just faham apa as liquid. Saturated vapor, saturated liquid. Betul. Mixture just mixture. Compressed as compressed. Kalau super vapor, kalau itu ni boleh nak jadi super vapor. Okay. This one ada mixture saja pun. Okay. Nama panjangnya saturated water vapor mixture. This one is saturated vapor. This one is superated vapor ataupun just superated. This one is compressed liquid or just compressed. Tapi kalau boleh kita letak compressed liquid. Kalau touch one saturated liquid. So that's it. So ada
Yang saturated vapor tu dekat point yang dekat depan kan?
Saturated liquid dia touching saturated liquid. Dia tak touching sini saja, kong mixture. Dia touching sini saja, jadi maksudnya X1 is saturated vapor. Saturated liquid. Cecair campur. tua terlebih terbawa terlampau. Seperti itu. Right.
Okay.
Sekali-kali yang lain kata kerja so far pada salah mungkin dalam 3 to 4% yang saya tengok dengan di tapi kita bahagian awal mungkin dia meningkatkan. Right. Okay, that's it for tonight. Ada soalan?
Alright, thank you.
Jumpa on Friday. Thank you. Bye.
Thank you, sir.
Bye.
Thank you, Prof.